Welcome to qnawire.
Okay, so we've got the following molecule. And we're asked about protons A, B, and C. And we are asked for the most shielded and most deshielded protons, which is to say which of the hydrogens is having the most electron density pulled from it by a neighboring atom, and which hydrogen is having the least amount of electron density pulled from it from a neighboring atom. Well, we should recall that hydrogens that are just on carbons with no other functional groups around, meaning nothing within basically 2 bonds or 3 bonds, depending on how you count them, should be basically the prototypical unshifted, undeshielded protons, right? In the absence of like electron donating groups, like heavily electron donating groups like silanes, right? But in the absence of that, we should expect the plain protons, right? Those just attached to carbons that are attached to other carbons and nothing else, to be the least deshielded, meaning B here is going to be our least deshielded, or the most shielded, or the lowest delta value, right? So the first answer is B, and then this is proton A is here, proton C is here. Okay, so then the question is, okay, is A, neighboring oxygen, going to be more deshielded than C, which is neighboring a carbon double bound to oxygen? Well, it turns out that neighboring oxygens are far more electron withdrawing than carbonyls are. Okay. We could consider that we're talking about the carbon that the hydrogen is attached to being attached to a electronegative atom, whereas for C, it's the carbon that is attached to the carbon that's attached to an electronegative atom. Whatever the case here, the answer is A. This proton is very close to this electronegative oxygen, which is deshielding it, right? So it's going to have a higher chemical shift or delta value. So the next answer is A. Okay, the next molecule we're looking at. It's like a methylphenyl. Oh no, it's kind of weird. It's like a methylbenzyl amide or amine or something like that. Whatever the case, we've got a hydrogen here, A. We've got a hydrogen here, C. And we've got a hydrogen here, B. Okay, so once again, we're asking which of these is going to be the least deshielded, right? Which is essentially going to be which of these protons is in the most normal environment, the most shielded, or the less close to electronegative things. And so what we'll notice is that this is essentially just a methyl group. It does neighbor a phenyl ring, and it does neighbor a nitrogen, but it's not a direct neighbor, right? We don't have a nitrogen on the carbon that bears the proton we're looking at. So A is going to be the most shielded, right? A is our first answer. And then for most deshielded, we're comparing B and C. Okay, one is going to be on our phenyl ring, that is, it's aromatic. The other is going to be what we would call an amide, an amine proton, not necessarily on the nitrogen, right, but attached to the carbon which bears a nitrogen. These actually aren't as deshielding as oxygens or alcohols are. And in fact, an aromatic is going to range from like 6 to 8 ppm, while being attached to a carbon that's attached to a nitrogen is going to range from like 2 to 3. So this electron deficient phenyl ring, in addition to some other effects that the reason why these are so deshielding is actually fairly complex, but turns out aromatic systems are very deshielding. So B would be the most